Hi students, now problem number 2. A particle of mass 5 units is moving with a uniform speed of v equal to 3 root 2 units in XY plane, in a two-dimensional plane along the line y equal to x plus 4. So the body is moving on an XY plane along a straight line. That the straight line is given by the equation y is equal to x plus 4. Find the magnitude of its angular momentum. Okay, when a body is moving along a straight line, first it must have a linear momentum. Okay, so the linear momentum will be along the direction of its velocity, direction of its motion. Okay, what is the path of this body? Is a straight line. Now, though the body is moving along a straight line, it may also have a turning effect about some fixed point. So, angular momentum in general, we have studied that only rotating bodies and the particles inside the body will experience an angular momentum. That is 100% sure. But sometimes a body which is traveling along a straight line may also have angular momentum with respect to some other point at a perpendicular distance from it. Now, let us investigate this problem. Now, the equation given for the direction of motion is what? Y equal to x plus 4. So, I give different values for x and find the corresponding values of y. So, for that first I will take x is equal to 0. When I substitute x equal to 0, then what will be y equal to 0 plus 4. So 0 plus 4 is equal to what? 4 itself. So 4 units. When x is equal to 0, y is equal to plus 4. Now one more value, if I will take x is equal to minus 4. X is equal to minus 4 if I substitute. Minus 4 plus 4 will be equal to 0. So this implies what? Y is equal to 0. So now on the plane on which the particle is moving, I have got the coordinates. When x is equal to 0, y is equal to 4. You can see here, this is the point where x is equal to 0 and this point corresponds to y is equal to 4. So at this point, I will mark the coordinates. So here the coordinates are 0, 4. Okay. Then when x is equal to minus 4 on the number line, you see here minus 1, minus 2, here minus 3, minus 4. At this point, what is the value of y is equal to? The height is equal to 0. So this is the point itself. So these 2 points lie on the direction of motion of the particle. Is it that these 2 points, namely 0, 4 and minus 4, 0, lie on the direction of motion of the particle. So if I join these 2 points, you can see here, if I join these 2 points and extend this on the other sides, this is the straight line along which the particle is actually moving. Can you see that this is the straight line? This straight line only is represented by the equation what? Y equal to x plus 4. Okay. Now, this is the right angle. So you see the height of the y-axis, height along the y-axis is 4 units. So this is 4 units. And the length along the x-axis also is what? This length also is equal to what? 4 units. So this triangle must be what? An isosceles triangle. Okay. So if you want, you can name the points as what? A, B, O. So OAB is what? A right angle triangle as well as isosceles. So this angle is equal to what? 45 degree, and this angle also is 45 degree, and this is 90. Okay. If I will draw a normal, from the point O to the straight line AB. So this is the normal, and I call this perpendicular distance as R. So that R is perpendicular to AB. So AB or B to A, this is the direction of motion of the particle, and its linear momentum will be along the straight line AB. Is it not that? So I will write first linear momentum of the particle. So what is the symbol for the linear momentum of the particle is small p. So small p is equal to what? Mass into velocity. Understand that? Now, with reference to the point O, which is at the perpendicular distance of r, the same particle will also have an angular momentum. Okay? So, angular momentum of the particle about the point O. So, angular momentum about the point O is given by L. L is equal to R into P. So, this is equal to M into B into R. Okay? So, here the information is given, we are going to substitute. Before that, M is given, V is given, R is not given. So, we have to find out. Okay? So, from this information, we have to find out the value of R. Okay, children? Okay. So, this is the point C I will take. Now, look at the triangle AOC, which is right angle at C. Okay? So, in triangle AOC, what is the value of sine of the angle 45 degree? This angle, sine A, this angle is 45 degree. So, sine of this angle must be equal to opposite side is R, and hypotenuse is having how many units? 4 units. So, R by 4. So, sine 45 is equal to what? R by 4. Sine 45 value is how much? 1 by square root of 2. So, this is equal to R by 4. Is it not that? So, sine 45 is equal to opposite side by hypotenuse. I have substituted R by 4. Therefore, R is equal to what? 4 by root 2. Okay. Therefore, R is equal to 4 divided by square root of 2. So, this is the value of R. Now, we are going to substitute for M, V and R. So, what is the mass is 5 units. Is it not that? Therefore, L is equal to M, P, R. So, this is equal to 5 units. Into velocity is how much unit? 3 root 2 unit. So, this is equal to 3 root 2 units. Into R is equal to what? 4 by root 2. So, this is equal to 4 by root 2. Now, root 2 get cancelled on numerator and denominator. So, this is equal to 5 into 3 is 15. 15 into 4 is equal to how much? 60. So, 60 units. Okay. Therefore, L is equal to 60 units. If you take the SI unit, means mass will be in kilogram, velocity will be in meter per second, and the radius will be in meter. Is it not that? So, the unit in SI unit you can substitute. Otherwise, you can leave it as it is. So, what is the answer is? The angular momentum of the particle is found to be equal to 60 units. I hope you must have understood well. Fine.